In Chapter 3, we're looking at things called arithmetic sequences or arithmetic progressions, and you may remember this phrase from GCSE, so I'm just going to pick this one to start off with, just looking at the examples in the book and picking the first one that strikes the eye. I get this one. So what's the pattern here? We're adding on 14 every time. So an arithmetic progression is defined by add the same amount every time. Now we know about negative numbers now, don't we? So this is an arithmetic progression because I'm adding the same amount every time. What am I adding? Well, I'm adding on a -6 every time, right? Sorry, I'm adding on a -7 every time. So both of these are examples of arithmetic progressions or arithmetic sequences. We can change those two words about AP or arithmetic sequence. Now, what does an arithmetic sequence look like in general then? Well, it looks like this. We start with a number, and then the next term is that number plus something, and then we add on the same amount again, and then we add on the same amount again. Okay, so A is the letter that we always use for the first term, and D is the letter that we tend to use for the amount that we're adding on, and it comes from D, common difference. Okay, so D for difference, the difference between the two numbers, and common difference is the word for it. We have a new notation, the nth term of the sequence. We previously just called it the nth term. We're now going to call it this, UN. Now, it doesn't always have to be a U, but the little subscript n tells us we're in the nth place. So for this sequence here, U4 for this sequence is 48. That just tells us the term number 4. Term number 1 for this sequence here is 6. Okay, so the nth term of this sequence, now we've got to be careful here. That's the first place, that's the second place, that's the third place, that's the fourth place. So the nth term is the starting point plus a certain amount of D. Now how much D have we added on? Well, we added on D every time, but we didn't do it the first time. So it's not n lots of D, it's n minus 1 lots of D. Okay, so the nth term is the starting point and n minus 1 lots of your common difference. So UN equals A plus n minus 1 lots of D. So if I have an example like this, UN equals 55 minus 2n, that's just telling us the nth term. So write down the sequence. Well, when n equals 1, this is 55 minus 2, that's 53. When n equals 2, and I suppose we'll do it this way, U1 is 53. U2 is when n equals 2, so 55 minus 4, 51. U3 equals 55 minus 2 times 3, which is 49, and so on. Okay. The 99th term in the sequence is called U99, for example. So you just put n equal to 99. This little subscript n is just a sort of ticker. It's a counter. It tells us sort of where we are. It's not timesing anything or doing any operations. It's just telling us we're the 99th place in the sequence. Find the first term in the sequence that is negative. Well, 55 minus 2n has to be less than 0. Find the value of n, and n turns out to be greater than 27.5 if you solve that inequality. So the first term in the sequence that is negative is U28, the 28th term in the sequence. What is U28? Well, put 28 into here, 55 minus 2 lots of 28, and that will tell you that you get -1. Okay, so that's everything in example 1 and example 2, really. And they can do things like in example 3, where they tell us the third term is 5, the 8th term is 20. So if I have an arithmetic progression, this is the nth term. If the third term is 5, then A plus 2 times D is 5. If the 8th term is 20, then A plus 7 times D equals 20. And if I want to know what the arithmetic progression is, I need to find A and D. And I can find A and D from these two simultaneous equations, solve those, you get A, you get D, and then you can write down, well, A, add D, add another D, add another D, and there would be our arithmetic progression. So just getting used to a bit of notation and a bit of, a slightly different way of thinking about these things, and that's everything in 3.1.